Okay, so in section 3.4, we will find the real zero of the polynomial function. Okay, we will find the real zero of a polynomial function, and which is also a solution of the equation. Okay, our target is finding the real zero or finding the solution of equation. So let's start from an example here. So we need to show that x equals to 4 is a zero for this polynomial function. Okay, and it also tells us to use this fact to completely factor factor p of x. So we are given a polynomial function. We need to check whether 4 is a zero of this function or not. So what is the criteria to be a zero of a function? So you have a number. At what condition that number will be a zero of a function? So once we substitute that number for every x in a function, if we get output equals to 0, then the given number 4 will be a 0 for this function, right? Or the other way is that if you find the remainder for this function, so you have this 4, you substitute 4 for every x here. Okay, we get p of 4. P of 4 is also a remainder, and if we get remainder equals to 0, then this 4 is the 0 of this function. The easiest way is that you substitute 4 for every x in the function. So we have p of 4 equals to 3 times 4 cube minus 4 times 4 square minus 48 times 4 plus 64. So in order to check whether given input is a 0 or not, you substitute that given number for every x. If you get your output 0, then given number is a real 0. Okay, now let's see if we get 0 here or not. So we have 3 times 4 cube is 4 square is 16, 16 times 4 is 64 minus 4 square is, that's a 16 times 4 is 64 minus 48 times 4. Okay, what is this? 8 times 4, that is 32. 4 times 4, 16 plus 392 plus 64. Okay, we can cancel this. 3 times 64, is it 192? Let's see. So 3 times 4 is 12. 6 times 3 is 18 plus 1, 19. So negative 192. So we get 0. See, when we substitute 4 for every x, our output is 0. It proves that our 4 is a 0 of p of x. Okay, if you get output 0, then that given input is a 0 of a p of x. Now if this is the case, okay, so we know p of 4 is 0. So we know p of 4 is 0. Now let's go back to our factor theorem. So here, so if p of some number is a 0, so we had p of 4, right? So if p of any number is 0, then x minus that number is a factor for the given polynomial. So we use factor theorem here. Okay, so let's use factor theorem. So from factor theorem, so we have from factor theorem, so we know p of 4 is 0. So if p of any number is equals to 0, then x minus that number, our number is 4, x minus 4 is a factor of p of x. Okay, this is from our factor theorem, but it has to be equals to 0. Okay, p of any number, if you get output 0 for any input, then x minus that input is always a factor for our polynomial p of x. Okay, now this is one factor for this polynomial. We need to find the other factor. Now if x minus 4 is the factor of p of x, what happens if we divide p of x by this factor? What do we get our remainder equals to? We get remainder equals to 0, right? So let's divide our polynomial p of x by this x minus 4 factor, because we need to factorize this function completely. That's our next problem. Okay, and we know we can always write our polynomial, one more time, we can always write our polynomial p of x as a divisor d of x times the quotient q of x plus remainder r of x. Now since our remainder is 0, so we can erase this part. So this is 0. See, our polynomial is in a factor form. Okay, so with the help of this division, we will factorize this polynomial function. So we already have the divisor, we already have one factor, which is let's take this as a divisor. Now let's find the quotient, which will be our next factor. Okay, now what method do you want to use to find the quotient? Do you want to use a synthetic division or a long division? Synthetic. Okay, let's go ahead and use synthetic division. So for synthetic division, so we need to find what is c. So this is our divisor. So let's compare our divisor with x minus c. So you compare your divisor with x minus c. And if you compare, what do we have for c? So c is 4. Do you all agree here? So for x, we have x. For negative, we have negative. For c, we have 4. So c is 4. Okay. Now we write down the coefficient of each term of our dividend. So we have coefficient of x cube is 3. Okay. Coefficient of square is negative 4. Coefficient of x is negative 48. Coefficient or the constant is 64. And there is no any missing term, right, in the descending order. So we have x cube, x square, x, and a constant. So there is no missing term. We divide this coefficient by our c, which is 4. So let's drop our first coefficient. You drop first coefficient and multiply by c. 3 times 4, 12, and right below next coefficient we have 12. We are not changing sign. Negative 4 plus 12, that is positive 8. Now we multiply 8 and the c. 8 times 4, that is 32. We are not changing sign. Okay, negative 48 plus 32, that is negative 16. Okay, negative 16 times positive 4, that is negative 64. So we have 0, and this 0 is our r of x. Okay, now our quotient q of x is, before that we need to know what is the degree. So what is the degree of p of x? 3. So if degree of p of x is 3, the degree of quotient will be less by 1. It means 2. So to have a degree 2, our leading term must have a x square term as a first term. So this is the coefficient of x degree, which is 2x square. Then you write in the descending order. So this is the coefficient of x, and this is a constant. So we have 3x square positive 8x minus 16. Now our p of x is divisor. Our divisor is x minus 4 time our quotient is 3x square plus 8x minus 16 plus remainder. Remainder is 0. Okay. Now we have the two factor. Now is it completely in a factor form? So x minus 4, we can't, this is the simplest form, but is there any way we could factorize this quadratic form trinomial? We need to try, we need to check. If you can factorize, you have to factorize. Okay, and here what method do we use? We did this a long time ago. We use the AC method because the coefficient of square term is not 1. So this is our a, this is our c. So we multiply a and c. So ac is 3 times 16. So that is 3 times 16 is 48, right? Now the next we write down each factor of 48. So one each pair of factors. So 1 times 48, that is 48. 2 times 24, that is 48. 3 times 16, that is 48. 4 times 12 is 48. Then we have 6 times 8, 48. So these are the pair of factors. We choose one pair of factor, okay, to rewrite our middle term 8x, positive 8x. Now which pair of factor do we choose to rewrite positive 8x? By adding or subtracting these factors. Okay, so 4 and 12, right? So how do we rewrite? So we need to have a positive 8x. Now what would be the sign here? 12 would be positive and 4 will be negative, right? So here, so we have x minus 4. Okay, just let me write down here. X minus 4 as it is. 3x square. So positive 8x is same as positive 12x minus 4x minus 16. So we rewrite this positive 8x as a positive 12x minus 4x. Okay, now we have the 4 terms. We make a pair of first 2 terms, pair of last 2 terms, and factorize. So we have x minus 4 as it is, x minus 4 as it is. Now in the first 2 terms, do we have any common factor? 3x is a common factor, right? So if we factor out 3x from 3x square, so we have x. So you divide 3x square by the common factor. So 3x square divided by 3x is x. Okay. Now let's factor out 3x from positive 12x. We get positive 4 minus. So from these last 2 terms, we have negative 4 as a common factor. So let's factor out negative 4. Negative 4x divided by negative 4, that is positive x. Negative 16 divided by negative 4 is positive 4. So we have this as a common factor. So we have x minus 4. So let's factor out x plus 4. This is a common. And the remaining is 3x minus 4. And this is our p of x in a factored form. So our p of x is equals to x minus 4 times x plus 4 times 3x minus 4. Now from here, can we find any, like we already know 4 is the real 0, right? Now let's find the remaining 0 for this function. So what will be the remaining 0 for this function? Can you pick a x such that your p of x is 0? We already know 4 is the 1. So 4 minus 4 is 0. And 0 times the remaining is 0. Now, can you just pick other real 0? We already know 4 is the 1. So what are the other real 0 here? Negative 4. Because, so if you substitute negative 4 here, negative 4 plus 4, this is 0. And 0 times remaining is 0. So negative 4. Whatever. So how can we make this expression equals to 0? For what x value? This is 0. 4 over 3. So 3 times 4 over 3 is 4. 4 minus 4 is 0. 0 times remaining is 0. So these 3 are the real 0 for this function. And these are also the x-intercept for this function. And these are also the solution for this equation p of x equals to 0. We have the 3 x values. So these are the real zeros. These are the x-intercept. And these are also the solutions. Okay. So this is our first example. Now, so now here we have this. So here we have a polynomial function, okay, and c is any real number. Now, if this is the case, so we have p of c is equals to 0. Okay, now let me double check here. They forgot to mention, okay, we don't know what is c here. Okay, let me add, okay, let me say here c is a real 0, okay, and just erase the remaining. We don't need the remaining. So let p of x, so let p of x be a polynomial function and c be a real 0. Okay, c be a real 0. Does it make a difference if we say a real number and a real 0? Do we have any difference? So what is the difference between real number and a real 0?
Real number is any number and real 0 is the x-intercept, so it's a specific.
Right. So real number is like any number, like from negative infinity to positive infinity. But if we are talking about a real 0, then those are the specific number. Those are the x-intercept. Okay, so we have any polynomial function p of x, and we know our c is a real 0, so we don't need this remaining. If this is the case, okay, if this is the case, Now if you substitute c for every x in your polynomial, you get the output 0, okay, or you get the remainder equals to 0, okay. Similarly, x minus this number is a factor of the function, okay, and c0 is the x-intercept of the graph p of x, okay. Like here, if we go back to our previous example, so we proved that 4 is a real 0, right? We proved that 4 is the real 0 for this function. So we have 4 as a real 0. If this is the case, our output, see, our output is 0, okay. Then x minus 4 is a factor, right? And 4 is the x-intercept, and we had here, so 4 is the x-intercept. So you have any number, if that number is a real 0, okay, then that same number is a x-intercept, okay. X minus that number is a factor, okay. And the next thing is that your output for that input is always equals to 0. So you should know these three concepts, okay. Once you know c is a real 0, the output is always equals to 0, x minus c is a factor for that polynomial, and c0 is the x-intercept. Now using this concept, let's fill this table. Okay, so we have this polynomial p of x, and we know the x-intercept is 5, 0. If this is the case, what is the real 0 for this p of x? What is the real 0 for p of x? We know the x-intercept for that function is 5, 0. Now what number is a 0 here? It's a 5, okay. So we don't know what is function here, but we can find the 0 here. So 5 is the 0. And what is the factor? What is the one factor for this p of x? X minus the 0, which is 5. So x minus 5 is the factor, okay. So in number b, we have h of x function, and we know one factor, x minus 3 is one factor. If this is the case, what should be the 0 for this h function? 3 is the 0. And what is the x-intercept? 3, 0 is the x-intercept, okay. Last, we have a g of x function, and we know -1 is the 0 for this g of x. If this is the case, what is the x-intercept? -1, 0. And what is the factor? X minus this 0, which is -1. And we end up getting x plus 1. So this is the factor for g of x. Okay, so let's do this much for today, and the remaining we'll do in our next class. And if you